So today in this class we discuss about the self-starting of synchronous motor by the damper winding. Basically, in this method to make the motor self-starting, a squirrel cage winding is also called damper winding is used on the rotor. We'll draw it for better understanding. And as we know that we are using the salient pole in the case of synchronous motor, and basically the number of poles are 2, 4, etc. Right. So these are the damper winding. And the damper winding consists of the copper bus embedded in the rotor pole face on the salient pole of the rotor, and the buses are short circuited at the end, and this will help start the motor as a three-phase induction motor. So these are some there are some following steps. Now we will discuss about it. So these following steps are: first of all, when the three-phase supply is given to the stator winding, of the synchronous motor, and the rotor winding is left unenergized the rotating stator field induces current in the damper winding. And the motor starts as an induction motor. So when the three-phase supply is given to the stator winding, so these are the stator frame, and this winding is called the stator winding. And suppose it is N, and it creates the pole that is N, and these are S and S, and the direction is like this, clockwise. So when the three-phase supply is given to the stator winding of the motor, that means synchronous motor, the rotor winding is left unenergized, and the rotating stator field induces current in the damper winding, because these are the closed copper coils, which is called damper winding. It is placed on the rotor poles, and as the flux cuts it, and it is also closed, so in that case current will be induces. So here it is written that the rotating stator field induces current in the damper winding, and the motor starts as an induction motor, because it follows the rules of electromagnetic induction, right? I hope it is understand. Now, so as the motor approaches the synchronous speed, it is nearly 90% of the it is nearly approaches the 90% of the synchronous speed. So the motor is excited with DC. Now resulting pole of the rotor phase the resulting pole of the rotor phase poles of opposite polarity on the stator, and so in that case this is the rotor pole, and if this pole is S, so the stator pole will be N, and if this pole is N, that means north, so the stator pole will be south, and vice versa. So in that case, and so because these poles are opposite, so in that case a strong magnetic attraction is set up between them, and we know that the phenomenon is known as magnetic locking. So the motor poles locked in with the poles of the rotating flux. Therefore the motor revolves at the same speed as the stator field, and we know that it is known as that is synchronous speed. And now we can see that because the parts of the squirrel cage portion of the rotor now rotate at the same speed, at the rotating stator field, that is the synchronous speed. So it follows the rotor follows the speed of the stator, that is the synchronous speed. These bars, so in that case, because we know that there is no relative motion, there is no relative speed between the rotor and stator, so therefore no flux will be induced, and therefore have no induced current in them, and this and removed from the operation of the motor. So it is then removed from the operation of the motor. So these are the methods of self starting of synchronous motor by damper winding. I hope you understand. So thank you.